Okay, this is going to be the second part of the notes to what we did yesterday, which was absolute value equations and inequalities. Yesterday we focused on the equations part. Today we're going to focus on the inequalities. This is what your page is going to look like once you're done with the notes. So go ahead and press pause on the video and copy this down. I'm going to assume that you already did that, so we're going to go ahead and just jump on in. All right, so let's look at the first part. It says absolute value of x is less than 2. We're going to do this the long way, which means we're going to go ahead and check every single one of these values and see if it works. So for example, I'm going to check -5 and see if it works. If I were to plug in -5 right here, I get the absolute value of -5, which is 5. 5 is less than 2. That's not true. So I'm going to go ahead and put a little x right here and say that it's not true. The next one, absolute value of -4. If I plug in -4 right here, I get absolute value of -4 is 4. 4 is less than 2. That is not true either. So I'm going to go ahead and mark that down. -3, absolute value of -3 is 3. 3 is less than 2. That's not true. Absolute value of -2 is 2. 2 is less than 2. That's not true either. And then I get to absolute value of, I do this one, it's the -1. I'm going to take the absolute value of -1, and that's 1. And 1 is less than 2. So I'm going to go ahead and put a check mark. 1, -1 works. 0, absolute value of 0 is 0. 0 is less than 2. That one works. So does 1. And when I check 2, absolute value of 2 is 2, and that's not less than 2. So again, all of a sudden it stops not working again. And hopefully you can kind of see that these bigger numbers aren't going to work as well. So if I were to tell you to graph something like this, what I would tell you to do is whatever this number is considered your boundary point. We're going to go ahead and circle the boundary points, which means I'm going to circle the 2. And when you do an absolute value, you also have to circle the other side. So I'm going to circle the -2. So I'm circling the 2 and the -2, and notice that all my answers are in between those numbers, the -1, the 0, and the 1. Anything that's not inside those numbers are not solutions to that absolute value. The weird thing is once we start considering like here, right, when you get like a decimal, like 1.9, is 1.9 going to work? Absolute value of 1.9 is 1.9, and 1.9 is less than 2. That's actually going to work. And so is 1.99999. So we can get really close to the 2, but as soon as I get to the 2, it doesn't work. So what I'm actually going to do is I'm actually going to go ahead and shade in all of these numbers because all of the numbers in between these two numbers work, including the decimals and the fractions. We can get really close to the 2, but I'm not going to fill in the 2 because when I get to 2, it does not work. So what I want you to notice is that all these are all the x values right here, from here to here. These are all the x's that work, which means my x's got caught between -2 and 2. Notice that there's only one set of numbers, so I'm going to go ahead and write it as one set. I know that -2 is smaller than my x's, or that my x's need to be bigger than -2, okay? But my x's also need to be smaller than 2. So I'm able to write this as one set because there's only one set of numbers that I see up there. That's the main thing I want you to get out of this is I was able to write it as one set. -2 is less than x is less than 2. You can think of this as my x's being sandwiched between my -2 and 2. Okay, so that's why I was able to write it as one set. It's all of these numbers right here. It's one set. So we're going to go ahead and write this is one set only. All right, I'm going to do this one a little bit faster. We're going to do the exact same thing. I'm going to check each value and see if it works. So I'm going to check each value here. I'm going to start off with the -5. -5, if I take the absolute value of -5, it's 5, and 5 is bigger than 3. So this is going to work. I'm going to put a check mark here. When I try -4, that gives me absolute value of -4 is 4. That is bigger than 3, so check mark here. When I get to -3, however, absolute value of -3 is 3. 3 is greater than 3. That is not true, so this is not going to work. In fact, all of these numbers here are not going to work. You can go ahead and verify that yourself. When I get up to 3, absolute value of 3 is greater than 3. That's not true either. And when I get to 4, absolute value of 4 is greater than 3. It is going to work, and so is 5. So, like last time, if I were to tell you to graph this, I would tell you to circle the boundary points. The boundary points are at 3 and at -3. And if you notice, this time, all the numbers in the middle of those two numbers don't work, but the numbers on the outside do work. And if we were to check the numbers like, so 3 didn't work, but 4 did. If I were to check the numbers really close to 3, like let's say like 3.1, 3.1, well, the absolute value of 3.1 is 3.1, and 3.1 is greater than 3, so 3.1 would work. So would 3.01 and 3.000001, they would all work. So all the decimal values on the outside or that are bigger than 3 are going to work, which means I'm going to go ahead and shade in all of these numbers here. But again, I'm not going to shade in the 3 because the 3 was something that did not work, okay? Same thing with all the numbers going in the other direction. All the numbers smaller than -3 are also going to work. What I want you to notice here is you do not have one set of numbers. In fact, you have two sets of numbers. You have the set of numbers that start here at -3 and go this way. That's one set. And then you have this other set of numbers that start at 3 and go the other way. Again, we're not including the -3 or the 3. So you have two sets of numbers. Since you have two sets of numbers, this one and this one, then you need to write it as two different sets. You cannot write it as a single inequality because you do not have a single set. So I need to write this as two different inequalities. This first inequality right here, this is the set of all the numbers that are less than -3. That means my x's need to be less than -3, or my x's, if I want to talk about this set, my x's need to be greater than 3. The main thing I need you to get out of this is when we do something like this, you are going to end up with you need two sets of numbers. You can't shortcut it and try to write it like this. It's not being sandwiched, so don't try to sandwich it between two numbers. You need to write them as two different inequalities. That took a while to do, so I don't want to be doing that every single time. What I want to do instead is I want to come up with a shortcut, and thankfully we have it. The shortcuts are going to be a little bit weird, so hopefully you can follow what I'm doing, and I'm going to try to do my best to kind of showcase what it is that we're going to get. Okay, so I got these split up into two different boxes. There's this box over here. Whoops. There's this box over here, and there's this box over here. On the shortcuts on the left, I want you to notice that you have the absolute value is less than, we're going to say an A, but really an A means a number. Okay, when you have the absolute value of x less than some number, or when you have the absolute value of x less than or equal to some number, the shortcuts are going to look very similar to each other. What's the shortcut going to look like? Again, the first couple of times are going to be weird, but just follow me through. To shortcut this, we're going to take this number, whatever that number is. In this case, I'm going to call it A. I'm going to take that number, I'm going to swing it to the front. When I take that number and I swing it to the front, I'm going to make it a negative. So if it was -4, if it was 4, I'm going to make it -4. Since it's A, I'm going to write it as -A. I swing it to the front, and then I write my new equality. -A is less than x is less than A. I'll say that one more time because I know that was pretty confusing. So I'm going to take this number, whatever it is out here, I'm going to swing it to the front. I'm going to make it a negative version. So I'm going to write it as -A. And then you're going to go ahead and write your inequality. So you're going to end up with -A is less than x is less than A. I'm going to go ahead and write that. So we have -A is less than x is less than A. All I did was I took that number, I swung it to the front, I made it a negative, and I was able to sandwich my x in between the negative and positive version of that number. Also, I want you to notice that when you do this, the absolute values are gone. I don't have that absolute value of x anymore. You need to get rid of it at this point. Okay, the exact same thing is going to happen on that second one. The only difference, so I'm going to take that A, I'm going to swing it to the front, I'm going to make it a -A, I'm going to sandwich it. The only difference is this time, because it's a less than or equal to, I need to put less than or equal to on both. So I'm going to go ahead and sandwich that x in between two numbers. What two numbers? Well, you take the A, swing it to the front, going to make it -A, less than or equal to x, less than or equal to A. Because again, this was a less than or equal to, so then these are also going to be less than or equal to's. And that's going to be my first shortcut. Right now, that might not make a whole lot of sense, but as we use them, it'll be a little bit clearer, okay? So that is the case when you have an absolute value being less than or equal to. The other case is when the absolute value of x is greater than or equal to. What are we going to do? Actually, you know what? Before we do that, let's go ahead and kind of reference this because we already did this. Look at the shortcut over here. The one that we were talking about. You see how this is a less than? This is a less than. What I ended up doing is I took that 2, I swung it to the front, I ended up with a -2 in the front, and what I would write is -2 is less than x is less than 2. And guys, that is exactly what we ended up with here. So hopefully we can kind of see where the shortcut kind of ends up, all right? So now we're going to try to work with this case. How do I do the shortcut here? How do I end up with 2 different sets? This one is the harder one. But again, so I know I'm going to end up with 2 different sets. The first set is going to be super easy. You're just basically going to copy this down. You're going to get the x is greater than a. You're going to copy it down exactly the way it's written. The only difference is you're not going to put these absolute values. Okay, so we're just going to copy it. X is greater than a. That's going to be my second set. So I'm going to write it way over here. X is greater than a. That's what's going to be my second set. My first set is the weird one. So I'm going to write the word or here. My first set, we're going to keep that x, but I need to switch this and I need to switch this. So this is the weird one. This is where the switches need to take place. When I say switch, I mean this is going to turn into a less than, this is going to turn into a -a. Keep, switch, switch. So let me go ahead and write that inequality. I'm going to keep the x, I'm going to switch the greater than to a less than, and I'm going to switch the a to a -a. That is going to be my shortcut for absolute values that have the greater than or equal to sign. How did that work last time? Well, let's see. I have this, x is greater than 3. That's the x is greater than something. The first one, the easy one I said, is to just keep it. Keep everything. So you're going to get x is greater than 3. X is greater than 3. There's one of my sets. That's the easy one. Also notice that the absolute value is gone. I don't want the absolute value here, okay? Now the weird one. The weird one is the first set where I keep this one, I switch, and I switch. So I'm going to keep the x, okay. I'm going to switch that greater than, and it's going to become a less than. I'm going to switch the 3 and it's going to become a -3. So that's exactly what we ended up with here. X is less than -3, X is less than -a. So hopefully we're trying to make those connections and we can kind of see what's going on right there, okay? The one on the bottom right here, it's the exact same trick. The only difference is because you're doing greater than or equal to signs, then you need to have that equal sign underneath. So let's just go ahead and practice it right now. Remember, we're going to end up with 2 different sets. I'm going to work with the first set. The first set is the easy one. I'm just going to keep, and keep, which means I'm going to write x is greater than or equal to a. Or here's the weird set. The weird set, we're going to keep, switch, and switch. Okay, so I'm going to keep the x. I'm going to switch that greater than or equal to, and now it's going to become a less than or equal to. And I'm going to switch that a, and now it's going to become a -a. So there are my shortcuts right there. I know that seems very weird, but trust me when I tell you, once you get comfortable with them, they become very easy to do, okay? So in order for me to use this, and we're going to be doing 4 examples right here. In order for me to use this and to be able to reference these a little bit easier, I'm going to go ahead and call this shortcut number 1. And I'm going to go ahead and call this shortcut number 2, just so it's easy for me to look up and say, oh, it's shortcut 1 or shortcut 2. All right. All right. So here are the 4 problems we're going to work with these shortcuts on. Just like the previous lesson, you may not get started on these problems until the absolute value is completely isolated. I don't want you trying shortcuts. I don't want you trying to split anything up until the absolute value is completely by itself. What do I mean by that? Well, let's check this one. They're going to check each one. You see this one? This one says the absolute value of something is less than or equal to 5. This absolute value is isolated. So yes, I can go ahead and get started on my shortcut. Can I get started on my shortcut on problem number 2? Well, I got to ask myself, is the absolute value isolated? Yep, I got the absolute value of something. And that's it on this side. So this one, yes, I can go ahead and get started on my shortcut right away. Let's look at this one. Is the absolute value isolated? Well, I see 2 times the absolute value of something plus 3. So no, I cannot get started on this problem until I isolate the absolute value. I got this extra plus 3 and I got this extra 2 out here. So before I even start this problem, I need to isolate the absolute value. And then when I look at this one over here, is this one isolated? Nope, I got the absolute value of something minus 11. Before I start this problem, I need to get rid of that minus 11. Then I can go ahead and get started with the problem. All right, so that's what I mean by isolating your absolute value. Just like we said earlier on this first example, this one, I can go ahead and get started with my shortcut because the absolute value is isolated. I got the absolute value of something is less than or equal to 5. The next question I'm going to ask you is, okay, should I be using shortcut number 1 or shortcut number 2? Because I have a less than or equal to, then that's going to match up with this one, which means I should be using shortcut number 1, which means I'm going to be able to sandwich that between the two numbers. How do I do that? Well, I'm going to take my number, whatever it is, I'm going to take that 5, I'm going to swing it to the front, and in swinging it to the front, it makes it a negative. So what am I going to write? I'm going to write negative 5. Oops, that's the wrong color. I'm going to write negative 5 is less than or equal to the stuff in the middle, which is 2x plus 3, is less than or equal to 5. So again, all we did was take the 5, swung it to the front, made a negative. That's this. We kept this thing here, and then we kept that last piece over here as well. Notice how it's sandwiched in between the negative 5 and the 5. Okay, now all I have to do is solve for x. In order for me to solve for x, I need to get the x by itself. I need to get rid of that plus 3. In order to get rid of a plus 3, I'm going to subtract 3. Normally, I would say, oh, subtract 3 from both sides. But here, there are actually 3 sides to this inequality. There's this side on the left. There's this side in the middle. There's this side on the right. So when I say we're going to subtract 3, we're going to subtract 3 from all 3 sides. That means I'm going to go minus 3, minus 3, minus 3. Subtract 3 on all 3 sides. When I do that, I get negative 5 minus 3. That gives me a negative 8. It's less than or equal to. These are going to go ahead and cancel out, and the 2x drops. And then is less than or equal to 5 minus 3. That's going to give me a 2. Is the x isolated? Nope. So I'm going to go ahead and divide everything by 2. Let's see, when I divide everything by 2, that means this is going to get divided by 2. The left side is going to get divided by 2, and the right side is going to get divided by 2. Negative 8 divided by 2, that's going to give me a negative 4 is less than or equal to x is less than or equal to 1. And that's what my solution set is going to look like. It's going to be all the x's between negative 4 and 1. If I were to graph this on a number line, your answers would look like this. Here's my number line. I'm going to do a really rough sketch. Here's negative 4. Here's 1. Your x's are sandwiched in between these two numbers. So it's going to, before I even do that, you need to circle your boundary points right away. So again, your x's are sandwiched in between the two numbers, which means I'm going to get all the numbers in between because remember, we only have one set. That means I get all these numbers in between. This is where your x's are going to live. The last thing I need to ask myself is, should I shade those numbers in? Because there's an equal sign down here, then we do shade in those bubbles. And that's what your graph of this solution set would look like. All right, that takes care of the first problem. Hopefully that wasn't too bad. Let's take a look at the second problem. I have the absolute value of 2x minus 5 is greater than 3. First thing I got to ask myself is it isolated? The answer is yes. Since it's isolated, then I can go ahead and start with my shortcut. I'm going to try to match this up, and I notice that I have a greater than symbol right here, which means it's going to match up with this one right here. So I'm going to be using shortcut number 2. Shortcut number 2, unfortunately, is a little bit more work because you need to come up with 2 different sets. The second set is the easier one because you just keep it exactly the way it is. So I'm just going to go ahead and keep that. It's going to say 2x minus 5 is greater than 3. So let me go ahead and write that down. That's going to be my second set. 2x minus 5 is greater than 3. Or the first set is the one that's weird. Remember, on the first set, you need to keep it. This thing needs to switch. This A needs to switch. So I'm going to keep it. That's going to be a 2x minus 5. This symbol needs to switch, so it turns into a less than. This number needs to switch, so it turns into a negative 3. Now that I have that, I can go ahead and start solving for it. I'm just going to solve each one individually. This part should be no problem at all. So I'm going to go ahead and add 5 to both sides. I get 2x is less than 2. Then I'm going to go ahead and divide both sides by 2. And I get x is less than 1. Or, for the other set, I'm going to add 5 to both sides. I get 2x is greater than 8. Then I'm going to go ahead and divide both sides by 2. And I get x is greater than 4. So that is my solution set to this problem. X needs to be less than 1 or x is greater than 4. Notice that I have that word or in the middle, which means I'm going to go ahead and have two different sets. If I were to graph this on a number line, the process for graphing it would be exactly the same. I would go ahead and draw a number line like this. I would graph my boundary points. Here's 1, here's 4. I'm going to circle my boundary points. Remember that these numbers are not sandwiched in between. You actually have two different sets. So I have the x's that are less than 1. All the numbers that are less than 1, which would be all the numbers going this way. And all the numbers that are greater than 4, which means all the numbers going this way. See how we ended up with two different sets? And then the other thing is, do I need a shade in the circles? Well, because there is no equal sign down here, then I do not shade this in. That means this graph is done. All right, we have two more problems, and then we're going to call it a day. Just like last time, I'm going to ask myself first, is the absolute value isolated? Nope, I cannot use my shortcut yet because the absolute value has stuff with it. So I need to get rid of all the extra stuff, which means I need to get rid of that plus 3. The way I get rid of a plus 3 is with a minus 3. These are going to cancel, and I'm left with 2 times the absolute value of x minus 3 is less than 6. I ask myself the question again, can I use my shortcut now? Again, the answer is no, because I still have that 2 that's bothering the absolute value. So I need to get rid of that times 2. The way we get rid of that times 2 is with a divided by 2. These are going to cancel, and I'm left with the absolute value of x minus 3 is less than 3. I asked myself the question again, can I use my shortcut? And finally, the answer is yes, because my absolute value is isolated. Now that I have my absolute value isolated, I'm going to go ahead and try to match up the shortcut. So when I look, I notice that this is a less than, which means it's going to match up with this one, which means I'm going to be using shortcut number 1, which means I need to take that a, swing it to the front, and sandwich my x in between. So I'm going to take this 3, swing it to the front, make it a negative 3, and sandwich it in between. So what am I going to end up with? I'm going to end up with a negative 3 is less than x minus 3 is less than 3. All I did is I swung that 3 to the front. All right, we're almost done. I just need to solve for x. I see that x has a minus 3 on it, so I need to add 3 to every single side. So I'm going to add 3 to the middle, add 3 to the left, add 3 to the right. When I do that, these are going to cancel. These are going to cancel. And it looks like there's nothing there on the left, and you're absolutely right, but you can't just leave it blank. I know a lot of students, they panic when they see nothing there, and they just go, oh, I'm going to get rid of it. And they just pretend nothing's there. I mean, guys, there's legit nothing there, but you need to write that, right? If there's nothing there, then you need to write that that's a 0. Now, the difference here is, again, right here, there is a 0 again, but because I have an x, I get to bring that down. So I don't have to write the 0 there. I don't need to write it as x plus 0 because I'm able to bring something down. Okay, that's the biggest difference. So, and then for that last part, I got 3 plus 3. That's going to give me 6. So it looks like I solved for my x. My answer is done. I just need to go ahead and graph this so I can show you what this looks like. Sorry, that line got a little crooked, but I'm sure you don't mind. It's from 0 to 6. I'm going to circle the 0. I'm going to circle the 6. Are the numbers sandwiched between two numbers? I'm asking, is the x's in between two numbers? Absolutely. The x's are between two numbers. It's between the 0 and the 6. So I'm going to go ahead and shade in the middle part. Notice I only have one set. And do I need a shade in the circles? The answer is no, because there is no equal sign down there. Last one. I got negative 9x plus 2 minus 11 is greater than or equal to 0. First thing I need to ask myself is, can I use the shortcut? The answer is no, because that minus 11 is causing the absolute value not to be isolated. So I need to go ahead and isolate the absolute value. I can do that by adding 11 to both sides first. You cannot do the shortcut until that absolute value is isolated. Now I can bring down that negative 9x plus 2 is greater than or equal to 11. I ask myself, can I take the shortcut? The answer is yes, because the absolute value is isolated. And now, since I can take the shortcut, I got to match it. So let's see, which shortcut are we going to be using here? I notice that this is a greater than or equal to, which means it matches up with this greater than or equal to. So I'm going to be using, unfortunately, shortcut number 2. As you can tell, I don't like using shortcut number 2. It's just a little bit more work. So shortcut number 2, we're going to do the easy set first. That's the one where you keep it, keep it, keep it. So I'm going to keep it, keep it, keep it, which means I'm going to write negative 9x plus 2 is greater than or equal to 11. Negative 9x plus 2 is greater than or equal to 11. Or on the other one, we need to keep it, we need to switch it, and we need to switch it. So I'm going to keep the negative 9x plus 2. Whoops, I'm going to keep the negative 9x plus 2. I need to switch the greater than or equal to, so now it's less than or equal to. And I need to switch the 11, so now it becomes a negative 11. Now that I have this, I'm going to go ahead and solve for it. So I'm going to subtract 2 from each side. This is going to cancel. I'm left with negative 9x is less than or equal to negative 13. The next thing I'm going to do is I'm going to divide both sides by negative 9. These are going to cancel, and what I'm left with is x is less than or equal to. Now, when I do this, let me go ahead and go over a couple of things. First of all, this negative divided by a negative is going to give me a positive. So I know my answer is going to be a positive number. Second thing, I know that I have this 13 over 9, and that is an improper fraction. And guys, it is okay for me to leave it as an improper fraction, which is exactly what I'm going to do. I'm going to leave it as an improper fraction like that and leave it as 13 over 9. Now, here is the part that's going to wreck some of you guys. So I really, really, really need you to focus right here. This answer technically is incorrect. And the reason it's incorrect because at this point, I needed to switch this sign from a less than or equal to a greater than or equal to. And you're going, why the heck are you able to, why are you switching it all of a sudden just because? Because there is a rule that says when you're dealing with inequalities, if you multiply or divide by a negative number, you need to switch the sign. I'm going to go ahead and write that as a little thought bubble. If you multiply or divide by a negative number, you need to switch the sign. Okay, that's a rule that's so easy to forget, and students get caught up on that one all the time. So because we divided by a negative 9, we ended up dividing by a negative number, I need to switch that sign, okay? We're going to go back, and I'm going to try to kind of test you guys a little bit just so we can kind of see where those scenarios occur, okay? So let's go ahead and continue with the next one for now. Just keep that in the back of your mind. I'm going to go ahead and solve the, oh, I forgot to write the word or, because we have this other one. I'm going to go ahead and solve for it, right? I'm going to go ahead and subtract both sides by 2. These are going to cancel. I get negative 9x on this side. I get 11 minus 2 is 9 on this side. And now the question becomes, do I need to switch the sign? Because I see this negative 2 right here. The answer is no, because remember what we did with that 2, we subtracted 2. And according to this thought bubble, you only need to switch a sign when you multiply or divide by a negative. I did not multiply or divide, so I'm not going to switch the sign. This needs to stay as a greater than or equal to. All right, let's keep going. I'm going to go ahead and keep solving for x. I see that I have a negative 9x. I can get rid of that negative 9 by dividing both sides by negative 9. That's divide by negative 9 on this side, divide by negative 9 on this side. These are going to cancel. I get x over here. I get a negative 1 on the right. And then I ask myself the question again, do I need to switch that sign? In this case, the answer is yes, because what I did here was I divided by a negative 9, which means I divided by a negative number. So I need to switch that sign. Instead of greater than or equal to, now it becomes less than or equal to. So those are my two numbers. I got x is greater than or equal to 13 or x is less than or equal to negative 1. It's really, really, really good practice for you to switch these numbers. Just because you always write your smaller inequality on the left and your bigger inequality on the right. So I'm going to write x is less than or equal to negative 1 or x is greater than or equal to 13 over 9 as my answer. We're pretty much done. Let me just go ahead and cover one more thing, because I know that this is a solid question I was getting asked all day. You say, Mr. Lechuga, check this problem out right here. Right here it says negative 8 is less than or equal to 2x is less than or equal to 2. And what did I do at this step? Right here, I divided by 2. But look at this. I got negative 8 divided by 2. So the question becomes, do we need to switch the sign there? And the answer is no. I know I see this negative 8. I understand that. But what did we divide by? We divided by a positive 2. We did not divide by a negative. We divided by a positive. Because I divided by a positive, I do not need to switch the sign there. So this answer was technically correct. We need to leave it as is. All right, guys, that's all the stuff I have for today. Hopefully that made sense. By the end of today, your page should have looked like this. If you have any other questions, please let me know.